The next topic is binomial expansion. We know that the sum of a and b is a binomial and it consists of two terms. And any expression of the form a plus b whole to the power of n is called a power of a binomial. We know the expansion of a plus b whole squared, right? It's going to be a squared plus 2ab plus b squared. And similarly, a plus b whole cubed, a plus b to the power of 4, and so on. These are all binomial expansions. We can find the expansion of a plus b. Let me take this example. We can find x plus 2 whole squared by doing x plus 2 into x plus 2, and we can also do the cubed by doing the same thing. But imagine it's to the power of 30. Won't it be really tedious? And therefore, people have derived a formula to expand this without having to multiply every single term. And also, you'll get it in like ascending or descending order, which is also very convenient. So you won't have to always add the like terms. When you do this, you get x squared plus 2x plus 2x plus 4. You got like terms, right? And you have to add them. But in this method that we're going to learn eventually, you won't have to do that. It's in ascending or descending order, depending on what the values of a and b are. So it's very convenient. And if you have like a huge power, you won't have to multiply this 30 times. And that's why it's so convenient. Now let's look at the formula. So if we have a plus b to the power of n, it would be a to the power of n plus nc1 into a to the power of n minus 1 into b. And it's going to be, the next one's going to be n c2, a to the power of n minus 2, and b squared. I have this like trick to remember that really helped me when I was doing the IGCSE exam. So you have this term, right? So the power of the first, this one, would be this minus this. And of the second term, it would be this number. So if you want to do this, it's going to be n minus r into b to the power of r. And so on until we get b to the power of n. So this is where NCR is the binomial coefficient of a to the power of n minus r into b to the power of r, where r is a positive integer and it includes 0. The general term, or the r plus 1 term in the binomial expression, is NCR into a to the power of n minus r into b to the power of r. This is very convenient, so try to remember. You won't have to expand everything to know a certain term. Also, this would be given in the formula sheet, and therefore you don't have to memorize this, but I'd recommend that you memorize it because it might take a long time to plug in the values or look at each of these terms and then try to substitute the values. So it's going to be really hard. So if you remember it, it's going to be easy. And that's all I have to say for this equation. And using sigma notation, we write a plus b to the power of n is the summation starting from r equals to 0 to n, which is, it means that it just goes from like 0, 1, 2, 3. It goes by increments of 1 until it reaches n. And this would be NCR into a to the power of n minus r into b to the power of r. This is the formula. This is gonna come in every single paper that you write. I have like solved a lot of papers and it came in almost every single one of them. So this is very important. And if you're gonna continue with A levels, then this will be in P1 and P2, but no, P3. But in P3, you're gonna have the value of n would be fractions, negative. Instead of having to do the NCR method, there's one more easy and fun method, which is called as the Pascal's triangle. It's in the name, literally Pascal's triangle. It starts with 0, and then we have 1, 1. And you're gonna add these two, and here it's 0, so it's gonna be 1 and 1. You keep doing that. So this is gonna be 3, 3, 1, 1. You do the same thing. And this is used to find the coefficient. This would, okay, let's take a plus b to the power of 4. We have 4c0, which is 1, 4c1, which is 4, 4c2, which is 6, 4c3, which is 4, 4c, 4, 1. You could either do this or this. And it keeps going on. It does not have an end. So this would be 10, 10, 5, 5, 1, 1. That's how you do it. Time to solve some questions. We have to find the coefficient of x cubed in this expansion. This is going to be 1 to the power of 10 plus 10c1 into 1 to the power of 9 into negative 3x plus 10c2 into 1 to the power of 8 multiplied by negative 3x whole squared and plus 10c3 into 1 to the power of 7 multiplied by negative 3x whole cube, and so on till negative 3x to the power of 10. This would be the x cubed term. Let's write this out. We can work out 10c3, it's 120 into negative 27 into x cubed. Therefore, coefficient is negative 3240. That's the answer. Now let's solve the next one. We have the same one. But now, instead of doing 1 minus 3x, let's take this as 3x plus 1. I'll tell you why this is more efficient. First, let's expand this. We have negative 3x to the power of 10 plus 10c1 into negative 3x to the power of 9 into 1 plus 10c2 multiplied by negative 3x to the power of 8 multiplied by 1 plus 10c3 into negative 3x to the power of 7 plus 1 and so on till 1 to the power of 10, which is 1, but yeah. The reason I did this is because if I want to find the coefficient of x to the power of 7, if I just wrote this like this, I would have to go through 8 terms in order to find the x to the power of 7 term. But doing this method, I found it in 1, 2, 3, 4, in 4 tries. And therefore, I use this. I just like flip them. Tan C3 is 120 to negative 3 to the power of 7 into x to the power of 7. The coefficient is negative 262,440. It's a lot. So we got the answers. Find the term independent of x in the expansion of this. The meaning of independent of x, it just means that there's no x term, it's going to be x to the power of 0. So that's what it means. It's just going to be a constant. Let's expand this. You just gotta keep writing this until you find a term that does not have the x term. And now we found it. It's 15c. Oh wait, I'm doing, sorry. That's 4 and 5. 15c5 into 2 to the power of 5. These two get cancelled, so that doesn't matter. We get 96,096. That's the answer. Now let's do the same thing for this. It's a lot of work, so you have to ensure that you don't go wrong anywhere. I'm pretty sure we found this here. It's this term. Because x to the power of 6 divided by x to the power of 6 is 1. So n9c3 multiplied by 3 to the power of negative 3 to the power of 3. This is going to be 84 into negative 27. It's negative 2,268. as the final answer. And with this, we're done with the whole chapter. I hope this video was helpful, and if you found it helpful, do subscribe and share it with your friends and family. Thank you.